Welcome grade 12s to Pedagogical Science Institute grade 12 revision series. What are we going to be looking at today? This is a video on geography grade 12 climatology, one of our first for the series, and we'll be looking at the topic mid-latitude cyclones. And let's just briefly look at the lesson outcomes for today's session. Now remember, this is a revision series, which means it's more on training you guys on how to approach your answering of examination questions than it's about the teaching itself. Of course, I'll be doing some teaching through the answering of questions, and for now I want us to just look at our updated DPE geography examination guideline, and I want us to just think about what aspects are you supposed to know from this section of work before you go into your exams. And yeah, I just want us to think about that for now. And of course, as we look at the different aspects that we'll study today, I will just do a bit of recap for you guys to just how I outline what do you have to know, what you have to understand for each aspect of the of your examination guideline. Now let's start. Let me just get my highlighter there. Okay, so we're looking at mid-latitude cyclones, as you can see. Now, what are they? Maybe that's one of the names that we need to know. What are they? How do we identify them? What's special about them? What features do they have? Now, and I'll say that the significance is in the name itself. It says mid-latitude cyclones. So this name is formed by different aspects, different ways. So we have the word mid, we have the word latitude, and we have the word cyclone. And in geography, these are concepts. They tell us something about the system that we study. So we're studying the system mid-latitude cyclone. It means mid means middle. It means they are found somewhere in the middle. The middle of what? Latitude. We have the word latitude, which means these systems are found in the middle latitudes. And we say that they are cyclones. And what is a cyclone? We say cyclone is a low pressure system. So we know that we are looking at low pressure systems that are found in the mid latitudes. And we'll briefly look at what are mid latitudes and what do we look at when we're thinking about mid latitude. So I'm just gonna do a brief diagram, smaller diagram here, showing us our global air system. So we have the line there, which is 0 degrees being the equator. Guys, forgive me for the skewed writing. I'm using a mouse to write. We have other lines of latitude. So we have the 30-degree line of latitude, and we have the 60-degree line of latitude. Let me just briefly outline that. And there at the poles, we have the 90 degrees there. Now, if you're looking at our system here, and I'm just going to draw it in the southern hemisphere only, of course, for now. We'll look at the other parts as we move along. Now, we are looking at our lines of latitude. We have 0, 30 degrees, 60 degrees, and 90 degrees. Which ones are at the middle? We will all agree and say that it's 30 and 60 degrees that are at the middle, which means these systems are found somewhere here between 30 and 60 degrees, and that covers what this part says, area of formation. So you need to know where these systems form, and we say they form between 30 and 60 degrees, and those are your latitudes or your lines of latitude. And it says here you also need to know general characteristics. One of the general characteristics, of course, is that is in the name itself. We said that these systems are cyclones, right? And what is a cyclone? A cyclone is a low pressure system, which means one of the general characteristics of these systems is that they are all low pressure systems, or they are low pressure systems. And these are the alternative names. They are also known as frontal depressions or extratropical cyclones. Now, why do we call them exotropical cyclones? The word tropical tells us that they are found somewhere in a tropical region, and the region that they are found in is this one, and we call this region the subtropical region. So that's one of their characteristics. And we say they are frontal depressions, which means that they have fronts. And yes, they have fronts. They have a cold front that we show like this, and they also have a warm front that we show like this with semicircles. So cold front has triangles as symbols, and a warm front has semicircles. So those are your characteristics. And of course they have a warm sector. Since they have a cold front, since they have the cold front, in front of the cold front it's the warm sector, and in front of the warm sector, this is our warm sector here. In front of the warm sector we have the warm front. Remember that we name fronts according to the air masses behind them. So behind a warm front is a warm sector, and behind a cold front it's your cold sector. So your cold sector would be somewhere here, and we say this is just one of their characteristics. Remember, area formation is between 30 and 60 degrees, and they're characterized by them having fronts. Now remember, with each front comes specific conditions. With a cold front, we'll expect that we'll have cold conditions coming with it. With a warm front, we'll expect cooler or slightly warmer conditions coming with that front. So those are the conditions, or rather the characteristics that are associated with the different fronts. Again, we look at conditions necessary for their formation. So what conditions are needed for a mid-latitude cyclone to form? Since they have fronts, and we said they have two fronts, they have a warm front and a cold front. Remember, a warm front is formed by a slightly warmer air. A cold front is formed by cold air. So those are the conditions that are needed. We need to have the presence of cold air and warm air. What else do we need? We need to have friction. So the friction is the one that ensures that fronts are formed, the frictional drag. So that's one of the conditions necessary for their formation. We need a frictional drag. And the frictional drag is the one that leads to the formation of fronts, as I said. And we also think about stages necessary for their formation. Remember, I'm just giving a brief outline of the section before we attempt to answer some of the questions. Now, stages of formation, we have 4 stages. We have the initial stage. We have the initial stage. We have the developmental stage, and we have the mature stage, and we have the occlusion or stage. Now remember, in the initial stage we say that cold air moves past warm air, where at the polar front. And what happens now when they move past each other? We say a wave is formed. A wave is formed, and when is the wave formed? The wave is formed at the polar front. Why does the wave form? It's because of the frictional drag. As the two air masses, remember, cold and warm air never mix. They never mix, but they meet. Where do they meet? They meet at the polar front. And where is the polar front? At the 60-degree line of latitude. So that's where the two air masses meet. And we say when they meet, since they do not mix, friction is going to be experienced at their meeting point. And where the friction forms, we start having a wave, like kind of a structure forming. And at the apex of that wave, we have this structure being a mid-latitude cyclone, a mature rather mid-latitude cyclone starting to form. And why do we say it's a mature mid-latitude cyclone starting to form? It's simply because at the apex of that wave, we have a low pressure system starting to form, which means our pressure starts decreasing towards the center of that system because of the frictional drag. And as a result, what happens is that we are going to have fronts forming, distinct fronts forming. And that takes us to the mature stage where we have your cold front fully formed, as you can see in this diagram, your cold front fully developed and your warm front fully developed, and your cold sector fully developed and your warm sector being behind the warm front being fully developed. And of course that comes with certain conditions associated with the different parts of the system, and that's something that you need to know. Associated weather patterns with a cold front, associated weather patterns with a warm front, associated weather conditions with also an occluded front. So those are some aspects that you need to know. We will visit these when we start answering questions. For now, I'm just doing a brief outline, so I'm not going to delve much on that. For now, we'll cover it through questions, and you also need to know the impact on human activities. So remember, with the impact on human activities, we look at social and economic activities, and we also think about the effect of mid-latitude cyclones on the environment. And since these effects may be good and bad, we ask ourselves, how do we counter the bad effects? So we look at possible precautionary and management strategies for these systems. So we think about that. And then the last part on your guideline wants you to be able to identify these systems on synoptic weather maps and satellite images. So look at a question that wants you to analyze a synoptic weather map, and we'll also look at a question that wants you to analyze a satellite image and answer questions based on that. And another facet that we think about is the impact of your high pressure systems, being your South Indian high pressure and South Atlantic high pressure, on the movement of these cyclones. So, and we also think about how do you actually interpret weather symbols on a synoptic weather map and on a weather station. Remember, weather stations are always found on synoptic weather maps. So that's what you need to know. There's going to be a question, of course, that looks at the cross section to a mid-latitude cyclone, so that's why I'm not going to talk about it now. And yeah, so those are the things that you need to know. Now remember, these systems, as we said, form between 30 and 60 degrees, which means that they form at the same location in the southern hemisphere and in the northern hemisphere. Remember, these lines of latitude are found in either hemisphere. Now, I want us to just briefly think about how do mid-latitude cyclones look on a synoptic weather map in the southern hemisphere, and how do they look in a synoptic weather map or in a diagram representation in the northern hemisphere. So that's what we look in the next slide. Now, You'll notice that we have two diagrams of mid-latitude cyclones. Remember, we said that they are characterized by them having fronts as one of the features. And we said the fronts that they have is a cold front and a warm front. And again, we think about how do you then identify in which hemisphere is this system. So we think about different elements, and these are aspects that you need to think about when you answer your questions. We think about the circulation of the system. You are always given the circulation of the system in a diagram before they ask you questions about it. Now, the first thing that we need to first revise maybe with each other is how does air really circulate in the different hemispheres? So remember, a mid-latitude cyclone is a low pressure system. Now let's think about characteristics of low pressure systems and high pressure systems in the different hemispheres. Now in the southern hemisphere, and I'm just gonna use the abbreviation SH, in the southern hemisphere, all low pressure systems will always circulate in a clockwise direction. So I'm just going to use arrows to demarcate this. In the southern hemisphere, all low pressure systems will always circulate in a clockwise direction. So that applies with low pressure systems. With regards to high pressure systems in the southern hemisphere, it means that they will circulate in the opposite direction, being the anti-clockwise direction. Guys, forgive me for the noise. I am at school as I am recording this, so it's lunchtime. Forgive me for the noise. I hope we can hear each other. Now let's apply this now. What happens in the northern hemisphere? So in the northern hemisphere, this is what happens. Forgive me for my skewed handwriting. I'm using a mouse to write. Now remember, in the northern hemisphere, then it will mean that our low pressure will be circulating in the opposite direction. And why is this the case? This is as a result of Farrell's law. Remember how is air deflected? How air is deflected is determined by Farrell's law. So that's an aspect we need to think about. This is the southern hemisphere. Southern hemisphere, northern hemisphere. It will mean that in our high pressure system, our air is circulating in the clockwise direction in the northern hemisphere. Clockwise direction. Let me just use arrows. Yeah, so that's what you need to remember first. Now I want us to now apply this knowledge on to our mid-latitude cyclones. One of the things we also need to remember in with low pressure systems, remember that pressure gradient force, it's a law. Remember, it's a law, pressure gradient force. And this pressure gradient force is saying that air will always circulate or move from an area of high pressure to an area of low pressure, which means that in a high pressure system, you'll have air moving out of the system. Air will always move out of the system in a high pressure system. High pressure system, air moves out of the system. While with a low pressure system, on the other hand, air will always enter the system, because remember, it moves from this high pressure system to a low pressure system, which means it enters the system. So those are some of the defining features of low pressure systems air always moves from a region of high pressure to low pressure. In a low pressure, it enters the system. In a high pressure system, it leaves the system. Remember, we said now mid-latitude cyclones are cyclones, are cyclonic systems, which means that they are low pressure systems. And since they are low pressure systems, it means that our air will be entering the system. If you observe the arrows in this diagram, let me get a laser. In this diagram, you see that the arrows are entering the system. But look at how are they circulating. For this diagram, these arrows are going in an anticyclonic, in an anti-clockwise direction. So since they are going in an anti-clockwise direction, which hemisphere is this? Go back to your diagram here at the bottom. You see that anti-clockwise direction defines the northern hemisphere. So if you look at it, it shows us that the system, the site is in the northern hemisphere. And what's the reason for that? It's because our air is circulating in an anti-clockwise direction. Then let's think about the other diagram on the side. Now, in the other diagram on the side, we have our arrows circulating in a clockwise direction. And since they are going in a clockwise direction, and this is a low pressure system, remember it's a mid-latitude cyclone. Cyclones are low pressure systems. It means that it is in the southern hemisphere. So that's just something you need to remember. They may give you such diagrams in the exam and ask you in which hemisphere is the system. Just think about the general circulation of the air into that particular system and use that to determine whether it's in the northern hemisphere or southern hemisphere. What happens if they didn't give you the arrows? Another thing that you can think about is the location of your cold front. So in the mid-latitude cyclone of the southern hemisphere, you notice that our cold front is facing upwards and our warm sector is upwards. So it's open upwards. Our warm sector is upwards. And that shows you that it's in the southern hemisphere. And our cold sector is below. Remember, why is it below? Where do you find your poles? The poles are always below the earth, or they are at the tip that is below your southern hemisphere, and that's where you find your colder regions. That's where you find your cold sector as a result. While where do you find your equator? Think about it in that way. Your equator or tropical regions that are warm are just above the poles, which means your warm sector will be somewhere there above, and that's where it's found there. So you also use that, the location of the different sectors and the fronts, to determine which hemisphere is the system in. With regards to the northern hemisphere, you'll remember that our poles are at the top, and since they are at the top in the northern hemisphere, you'll find your low pressure system somewhere there at the top. What's this? You'll find your low pressure system at the top, and you'll also find your cold sector at the top, and you'll find your warm sector at the bottom. Remember, because the equator is somewhere below the pole in the northern hemisphere. So that's an aspect that you need to think about when you are asked, or when you get a question asking you in which hemisphere is this system. Think about how is the air circulating in this system, and how is my air moving. If they ask you if it's a high pressure system or low pressure system, if it enters the system, it shows you that it's a low pressure system. With regards to the hemisphere, you think about the location of your cold sector and your warm sector of the different systems. Okay, yeah, I think we can start answering some questions. Let me just move on to the next slide. Okay, the first questions we're gonna look at is multiple choice questions. Without wasting time, remember that the first video on the series, just look at the link above here. It gives, what's this, the first video of the series just takes you to certain exam skills that are necessary for a geography examination. And we also do address how do you answer some multiple choice questions and how do you also approach long questions as a result. So for now, let's just outline a few tips into answering multiple choice questions. The first tip says you must read the question and option given. So read your question carefully, read the options given, and then what do you do afterwards? You put on your content cap. What is a content cap? So try to rationalize which one is the most correct answer and why does it qualify as the most correct answer and why are the other options wrong? So you ask yourself that. If you are not sure which one is the most correct answer really, use the elimination method. So eliminate the totally most incorrect questions, or what's this, options, and then that will in a way take you to two options that are usually partially correct, and from the two you need to choose the most, as you can see, the most correct answer. So you choose the most correct answer out of the two options. Let's move on to the next part. Let's look at some questions then. The instruction says choose the correct option from the alternatives that are given. So we're supposed to choose the correct option. That's the key word. Sometimes they say choose the incorrect option, but so you need to be careful of that. Read the question carefully. You're supposed to choose the most correct question. You are looking for the most correct answer then. 1.1, mid-latitude cyclones are also known as A. Frontal depressions, B. Moisture front, C. Depressions, D. Anticyclones. Which one is the most correct one? Now, remember we are looking at mid-latitude what? Cyclones. And the cyclone is a low pressure system. What's the opposite of cyclone? It's anticyclone. And sorry guys for that, it's the intercom. Remember I'm at school. Remember that we are looking at cyclones, and the opposite of cyclones is anticyclone, which means D is the most incorrect answer there for this question. D is most incorrect. So let's say you're unsure, you will eliminate D. And then what's another one? Although mid-latitude cyclones have fronts, but do they have a moisture front? No. So they have two distinct fronts, being the cold front and the warm front, which means moisture front is incorrect for this option. We'll cover what a moisture front is when we do subtropical anticyclones. Remember that now we have two options on the screen. We have A and C, and we acknowledge that mid-latitude cyclones are depressions, but in as much as they are depressions, they are a special kind of depression. They are a depression that has fronts, right? So the most correct option then is a frontal depression. So A is our correct answer. A is our correct answer, so just note it down there. Yeah, so that's what you do. Elimination method, that's what you do. Just took you through the thinking process that you should employ in trying to answer these questions. And then we think about 1.2. Mid-latitude cyclones move from east to west, B, southeast to northwest, C, south to north, D, west to east. Which one is the most correct answer? So let me just draw a diagram, our global air circulation diagram. And we see that at the center of the diagram we have what? The equator at 0 degrees. And then we have our 30-degree line of latitude being the subtropical high pressure belt. Remember you did the belts in grade 11. At 60 degrees we have our subpolar pressure belt, and at 90 degrees we have our polar high pressure belt. And remember that here between 60 and 90 degrees we have polar easterly winds, which means between 30 and 60 we have our westerly winds. Remember that we have alternating winds in each region. So which means between 5, let me just be specific and say between 5 degrees and 30 degrees we have our easterlies, our tropical easterlies. Here we have our subtropical westerlies. So mid-latitude cyclones, remember we said they form between 30 and 60 degrees. They say here they move from east to west, southeast to northwest, south to north, west to east. So since they are found between 30 and 60 degrees and we have subtropical westerlies between 30 and 60 degrees, it means that these systems move from west to east. Remember we name winds according to where they originate. So between 30 and 60 degrees the winds there originate from the west to the east, which means our mid-latitude cyclones will move from the west to the east, which means D is the most correct answer and the others are incorrect. So that's the reasoning behind that. And then we look at 1.3. Mid-latitude cyclones occur between. So we've answered that question. They occur between 30 and 60 degrees. Lines of latitude. Remember, this is a line of latitude. This is a line of longitude. And we say they form in the mid-latitudes. They are mid-latitude cyclones, which means they form in the latitudes, and those latitudes are 30 and 60 degrees, and that means B is the most correct answer. Okay, let's go to question 1.4. A series of mid-latitude cyclones is known as A, group of mid-latitudes, B, cluster of mid-latitudes, C, family of mid-latitudes, D, variety of mid-latitudes. Now, this is something that you need to remember. There is no such a thing as a group of mid-latitudes, a cluster of mid-latitudes, and a variety of mid-latitude cyclones. And remember that when mid-latitude cyclones occur, they occur subsequent to each other. They occur one after another, and we call that a family of mid-latitude cyclones, of mid-latitudes. And 1.5, the diameter of a mid-latitude cyclone ranges from 100 to 400 kilometers. B, 500 to 1,000 kilometers. C, 10,000 to 14,000 kilometers. D, 1,000 to 4,000 kilometers. Which one is the most correct answer? And for this one, it also wants you to just remember. So the answer there is D. The diameter of a mid-latitude cyclone ranges from 1,000 to 4,000 kilometers. And they are that huge, that big. That's just one point that you have to remember too for examination purposes. So that's how you approach multiple choice questions. I've just selected 5, and thanks to Saibono, Gauteng Department of Education, SIP material for this wonderful multiple choice. I hope it covers some aspects of the mid-latitude cyclone section, and you can remember some of the stuff from it. For now, let's move on to long questions. Long questions. Now, how do you answer long questions? Again, put your content cap on. So with these ones, from the start, you should to put in your content cap on. So why is it important for you to do so? You must first study the annexure thoroughly. Read all the questions carefully. Highlight the action words. Do they want you to account? Do they want you to give? Do they want you to explain? Do they want you to demonstrate? Do they want you to show? Do they want you to sketch? Do they want you to draw? What do they want from you? Those are action words. Think about how you will approach the question. So if you've highlighted the action words, you can now think about how do I approach the question, and as a result, it will lead you to the last step. Go for it, answer the question, give the correct answer. Do not explain if you are not asked to explain. If they want you to state, it's usually a small phrase. Don't write a paragraph in a state question. If they want you to write a paragraph, don't write small phrases. Write in a sentence format, in a paragraph format. So always look at what they want from you and follow the action words given. Okay, let's look at our first question. Okay, let's look at the first question. Figure 1.3 shows a mid-latitude cyclone on a synoptic weather map of Southern Africa. Now, this is a question from the November 2020 Geography NSC final examination. So we're just gonna study the annexure as we outlined the previous slide. It's the first step before we can attempt to answer questions. So if we look at your annexure here, we have different features. We have the date. So we have the date here. The date is 2020 August 25, and ask yourself what season is this. So in South Africa, normally around this time, that will be your winter season, your late winter, August. And again, we have a label here, label A. So label A is showing you a front of some sort. Remember, this will be your cold front. How do we see that this is the cold front? It has your triangle symbols. We have a semicircle symbol here, which means it's your warm front. And we have a mixture of the two at A. So that means that is your occluded front. And if you observe the pressure here, we have 996 hectopascals. We have 992 hectopascals. So those are some of the features that you can identify from the structure or rather from the annexure here. And we have South Africa along the lines, along the borders. You see from the borders that is South Africa, and we have a low pressure system there at the coast, that is your coastal low, and you have your high pressure closer to the interior. So that is your South Indian high pressure cell. So these are just some of the features that you can identify from the synoptic weather map. And let's just look at what questions are they going to ask us from there. So when we say study your synoptic weather map. That's what we're saying. Look at the features that are shown, predict what they may ask you, or rather identify features from this weather map, and before you can actually look at the question and try to see what they will be asking you. Let's get to question number 1. 1.3.1. Give evidence from the diagram that suggests that weather system A is a mid-latitude cyclone. Give evidence from the diagram that suggests that weather system A is a mid-latitude cyclone. Remember, what is a mid-latitude cyclone? What characterizes it? We say that it is a system that has fronts. So if you look at the diagram here, remember, when they say give evidence, you need to give visible evidence. So it has fronts here. So the fronts are showing you that it is a mid-latitude cyclone. So there is a cold and warm front, fully visible. There is a presence of an occluded front. So here at A, we have an occluded front. So that shows you can only have an occluded front in a mid-latitude cyclone. And remember, occlusion is a stage that you can only find in a mid-latitude cyclone. And there's also a low pressure. So where do you see the low pressure? Remember, if you look at, we have 996 hectopascals, 992 hectopascals. So the pressure at A, at the center of the system, is less than 1000 hectopascals. And that is showing you that this is a mid-latitude cyclone. And again, you have the sectors. You have your warm sector up here. Let me just get a laser. So you have your warm sector up here, and you have your cold sector down here behind the cold front. So you have warm sector in front of the cold front, behind the warm front, and you have your cold sector in front of the warm front and behind the cold front. So these are the features that you can use to identify the feature that is being postulated in the diagram. Let's look at the next one. Mid-latitude cyclone is moving from west to east as indicated by the symbol of the cold front. So the cold front symbol is showing you that this system is moving towards that direction, towards the east, coming from the west. So that's another feature that is showing you. Remember, and remember, the occlusion that is taking place there is cold front occlusion, simply because the cold front is catching up with the warm front, and as a result you will have your system being a mid-latitude cyclone. So those are pieces of evidence that you can visibly identify from the diagram. And again, you can think about the last reason here at the top. So the last reason is the date. Remember, this is late August, the 25th of August. So that is winter, and we say these systems occur throughout the year but affect South Africa only in winter. So that's another reason. Question number 2, 1.3.2. Why does a system originate at the polar front? So why does it originate at the polar front? Remember, remember that we have the meeting of the two air masses at the polar front. So we have cold, dry polar air meeting warm, moist, subtropical air masses at the polar front, and the frictional drag occurs at the polar front. Frictional drag occurs at the polar front, where the two air masses meet but do not mix. Remember, they meet but do not mix. And where do they meet? At the polar front. Why at the polar front? Because of the frictional drag. As the two air masses, cold polar air and warm subtropical air, meet each other at that point. Question number 1.3.3. Give a reason for the direction of movement of this weather system. So it moves So remember guys, there's a difference between circulation and movement. So here we are looking at the direction movement. Direction movement, not the circulation. So the difference between the two is that movement looks at, is it going southwards, westwards, northwards, eastwards. Is it coming from the west going to the east? Is it coming from the east going to the west? And so on and so forth. And in this case, we are saying that this system is moving from west to east. And why is that the case? Because it occurs or it forms between the between 30 and 60 degree line of latitude. And if I can just get a pen to demonstrate that. So if this is my diagram showing me my global air circulation, remember that you have 0, you have your 30, and you have your 60. And then you have 90 at the poles. Remember I showed you that. So between 60 and 90 you have your easterly winds, specifically polar easterlies. Between 30 and 60, that's your subtropical region. So you have your subtropical westerlies. And this system moves from west to east as driven by your subtropical westerlies or as driven by the subtropical westerly wind belt or tropical westerlies, whatever way you want to put it. It is steered or driven by westerly winds. It's located in the westerly wind belt, which is 30 to 60 degrees, and it is also driven by jet streams. Question 1.3.4. Why is the cold front associated with severe weather conditions? Now, remember that the cold front is formed by cold air. And behind the cold front, you find your cold sector. And the cold sector is characterized by cold air. And again, we think about pressure gradient. Again, that's another point. And remember, what does pressure gradient say? It says that air will always move from a region of high pressure to low pressure. Now, in front of the cold front, what happens is that due to the presence of the warm sector in front of the cold front, when cold air comes and meets the warm air that is from the warm sector, the cold air will always sink, and when it sinks, it pushes the warm air upwards rapidly, and this causes rapid condensation to happen, leading to the formation of cumulonimbus clouds in front of the cold front. And what happens then is that we are going to have very cold temperatures forming as a result, because remember, cold front, cold air. Cold front is formed by cold air. So what's going to happen is that you're going to have these cold conditions. And why do you have cold conditions associated with the cold front? Number one, it's because of the steep pressure gradient. So your isobars are closer together, and we are saying that closer together, that depicts that we have a high concentration of these high pressure air or this cold air, and as a result it's going to cause the rapid upliftment of this air, and that's going to lead to rapid condensation, of course, as a result, which causes cumulonimbus clouds, and cumulonimbus clouds are associated with what? Severe heavy rainfall as a result. So that's why cold front is associated with severe weather conditions. And what's going to happen as a result? You're going to have the barking of air. So the wind direction is going to change, it's going to bark, and that's what we mean, it's going to change. And those are the features that you have. Now, why does the cold front of the mid-latitude cyclone have a positive impact on agricultural activities in the Western Cape. Now you need to give 2 reasons, 2 reasons. Each reason you give is worth 2 marks. So now, what does the cold front have positive impact? Now remember that a cold front is associated with what kind of clouds? Cumulonimbus clouds. Cumulonimbus clouds are formed by severe heavy was rather characterized with severe heavy rainfall, and this heavy rainfall leads to water, right? Rainfall means water, and more water means we can practice agriculture. We can irrigate our plants, and it means that again, since it happens in the winter season, it means that we're gonna have winter rainfall, which is a good economically for the yield, for the crop yield in that particular farm. So increased rainfall fills up what? Dams, rivers, JoJo tanks, which impacts positively on agricultural sectors. How does it impact positively? It enables irrigation of winter crops to occur, which means we will have enough food for local markets, and again it means that we are going to have more agricultural production, and we are going to practice, or rather will be able to export some of the produces or the products that we yield from farming, and it means that low temperatures will be very ideal for some of the crops to grow, as some strive or thrive in cold winter. Sorry for that disturbance. It was an intercom. I just muted the recording. So let's just continue. We said that cold conditions can kill pests that can eat crops. So when it is crazy, when it is very cold, it's gonna kill some of the pests that may impact negatively on some crops that we are planting. There will be more infiltration, which causes more water to be available in the water table, or rather more groundwater to be available, which is very good for some of the farms that depend on groundwater for the irrigation of plants. It's gonna again supply us with jobs, so the job market from agriculture is going to increase because more people will be hired as a result of this, and again we'll have clean again this rainwater will clean polluted rivers, as all the polluted water will be washed away and pollutants will be removed from the water, and again it's going to improve pasturage for livestock grazing, so we will have these green grass getting water, which is good for livestock. And the soil fertility again increases due to alluvium from flooding. So when it floods, remember all the fertile soil is washed from one region to the other. So that is good for farming, because some sections of land will get very will get rich minerals or alluvium, and again it contributes to the food production or food security, which is good again for agriculture. And lastly, we'll have the availability of water for livestock if we are practicing livestock farming. So those are some of the points you can think about. Yeah, I think this is the last question for the November 2020 Geography NSC final examination on mid-latitude cyclones. Let's look at a different question that tests a different skill. Okay, so 1.3 again, refer to figure 1.3 and extract on mid-latitude cyclones. So this is an exam paper from this year, the June 2021 Geography Senior Certificate and National Senior Certificate Examination. And they got this extract. This is the copy of the annexure. So let's do the first step. Let's study the annexure. Put your content cap on and let's look at what can we get from this article. So figure 1.3, mid-latitude cyclones over the Western Cape. South Africa is among a handful of countries that experience winter rainfall in some areas and summer rainfall in some others. The southwestern tip of the country has a Mediterranean climate with hot, dry summers and cool, wet winters. So it says here the region has Mediterranean climate, right? So what is that? So let me just get what is that for us. We will outline that as actually when we answer questions. And again, it says this is because mid-latitude cyclones migrate further north during winter, allowing the edge of the cold front arm to sweep across the southernmost part of the country. This results in frontal winter rainfall over the Western Cape. The movement of the cold front over the Western Cape is generally associated with a variety of weather changes. These cyclones can have a positive or negative impact on tourism. Now, if you look at this article, they're most probably going to ask you what is to say something about the general climate of the southwestern tip. They most probably going to ask you why do mid-latitude cyclones migrate northwards in winter only, and why not in other seasons? Why do they affect South Africa in winter specifically? And they're also going to ask you about maybe the positive or negative impact of mid-latitude cyclones on tourism, and again the associated weather changes that these systems come with. Let's look at some of the questions. First question, name the type of climate that is found at the southwestern tip of the country. Now, in a way, this is a comprehensive kind of a question. You see, it's 1 mark, so they want one, it's like one answer really. So you just look at your article. So there's a part that said the southwestern tip of the country has Mediterranean climate. So that is the answer. The answer is Mediterranean climate. And for your own benefit, what is Mediterranean climate? So this is climate that is usually found or that occurs in the western tips of continents, and it occurs roughly between 30 and 40 degree line of latitude, and it's characterized by hot, dry summers and very mild, wet winters in those particular regions. So that is that. Let's look at the next question. Describe the climate experience at the southwestern tip of the country during winter as indicated in the extract. So in the extract, they showed you that during winter, you always have cool, wet winters as a result of frontal rainfall. So that is a description of the climate that is. Okay, next question. Why do mid-latitude cyclones migrate or move further north in winter? Now, it takes us to this aspect, very important aspect. And let me just draw my global air circulation. Ooh, my uneven circle. So you have your 0 degree line of latitude, you have your 30 degree, you have your 60 degree, 30, 60, skewed 60, yeah, 60 degree line of latitude. Now it brings us to the next aspect, the ITCZ. Now, here's the first reason. As a result of the shifting of the ITCZ to the northern hemisphere, it will be summer there. Now, remember that when it is winter in the southern hemisphere, it is summer in the northern hemisphere. And because of this fact, we know that at the equator you find your ITCZ. Remember, you were taught this in grade 10 and 11. You find your ITCZ at the equator. And what is the ITCZ? It stands for Intertropical Convergence Zone. And which pressure systems are associated with convergence? Those are low pressure systems. And since low pressure systems are associated with convergence, it means that your ITCZ will always go to the hemisphere where it is summer or where the low pressure systems are dominating in terms of your monsoon winds. When summer monsoons are dominating, that's where your ITCZ will go. And if it is summer in the northern hemisphere, it means that your ITCZ will move to the northern hemisphere. And when it gets to the northern hemisphere, it means that it's going to now migrate with your high pressure systems that are found in the subtropical high pressure belt, being at 30 degrees. And we say that when the ITCZ goes to the northern hemisphere, it moves with these high pressure systems to that, or rather to what is northwards. And as a result, when you have your mid-latitude cyclones between 30 and 60 degrees, when the high pressure systems move northwards, they move along or pull with them or allow for the free movement of mid-latitude cyclones to the northern hemisphere as a result. Yeah, so that's just one of the reasons. If you think about the next one, it says that the anticyclones will be able to move further north, allowing the mid-latitude cyclones to migrate further north too. So when the ITCZ goes to the northern hemisphere, it allows for anticyclones to move further north, which allows for the migration of free movement towards the north of the mid-latitude cyclones. So let's look at the next question. Describe the changes in the weather associated with the passing of a cold front over Cape Town. Now, remember we said that in the southwestern tip of the country, you get to have winter rainfall, and this winter rainfall is caused by what? It's caused by these systems called mid-latitude cyclones. Because remember that as they are cyclones, in a way they are associated with unstable weather conditions, which means they're associated with some form of precipitation. So what happens is that when the cold front approaches, it causes the temperature to decrease because it's associated or made up by this cold air. And what happens to the pressure? The pressure is going to increase. Remember the relationship between temperature and pressure. They are always antagonistical, opposite, and inverse to each other. So when temperature increases, pressure is going to decrease. When temperature decreases, as in the case of this cold front approaching, the pressure is going to increase. And what happens again? We have the wind speed. What happens to the wind speed? We're going to have strong winds, or roughly winds that are above 20 knots. To avoid making such a speculation, but strong winds are usually characterized by that, and these winds are caused by the cumulonimbus clouds that will be there. So the wind direction will change, and we call that bucking. Cloud cover will be overcast, or you'll have cumulonimbus clouds, and the precipitation will be heavy rainfall or thunderstorm or snow. So some regions usually snow. So that's just one of the possible answers as precipitation. So especially high-lying areas usually experience snow as a result of this. So these are the changes associated with the cold front. Always, it doesn't matter if they gave you an extract or they gave you a diagram or they gave you a multiple choice question, anything. When they ask you, or rather each time they ask you about the weather changes associated with the cold front, always list these reasons. Temperature decreases, pressure increases, they are opposite to each other. Wind speed will have strong winds, and the wind direction will change as a result of this, and we call that backing in the southern hemisphere. Remember, it's backing in the southern hemisphere, and in the northern hemisphere we call that veering. The change in wind direction in the northern hemisphere is known as veering. I'm using my mouse to write, it's a bit, but you get the point. So that is what happens. Next question. In a paragraph of approximately 8 lines, explain the negative impact of the cold front. So let's look at keywords. They said you must explain. That's your action word. And what are you explaining? Negative impacts of a what? Of a cold front. On what? On tourism. They were specific to tourism. We don't want to see you talking about the environment. You must talk about tourism in Cape Town. Reason number 1, possible negative impact. The cold front is associated with what? Cumulonimbus clouds, which can lead to heavy rainfall, which may cause flooding. Remember, flooding is a negative impact of cumulonimbus clouds or of mid-latitude cyclones. So when you have flooding, that can have a negative impact on tourism. And what will happen as a result? Tourists may be confined indoors during the rainy days, and as a result, they are not going to visit tourist attraction sites. And as a result, those attraction sites will not make enough income because they have less number of customers. And that will decrease the profitability of that particular tourist site. And what will happen again? Flooding may cause heavy rainfall, we know that, and strong winds, which may damage this infrastructure of those particular regions. So that's another negative impact you can think about. So when the infrastructure is damaged, it will lead to less tourists coming to that particular region. It will mean that more money will have to be, or rather funds will have to be redirected into fixing that infrastructure, which may again limit the profitability of tourism as a result. Again, strong winds and heavy rainfall may delay flights to the tourist locations, decreasing the quantity or the number of tourists visiting the region. So that's some of the negative impact. And again, when there's a decrease in temperature, people will be uncomfortable with visiting outdoor areas, so they may be confined indoors. And again, it may not be enjoyable for some tourists to be outside in these cold conditions, and as a result, they will spend more time indoors than on tourist attraction sites, which leads to less economic benefit, and less economic benefit means less contribution to the GDP. Less contribution to the GDP means that there is no growth in the tourism sector, and people are gonna lose jobs when these tourist attraction sites are not making enough profit. And again, you can think about when the infrastructure gets damaged and funds have to be redirected into fixing infrastructure, that may mean that the owner of the tourist attraction site has to reduce the workforce in order for them to afford the funding. And that will mean people will lose jobs as a result. And when they lose jobs, it will mean the unemployment rate will be high. There will be pressure for the remaining workers in that tourist facility or site working there, and they'll work under pressure, and they may not give a good enough services to the visitors, which may defer or lead to people or customers not visiting the site because of poor services that will be offered there. So you can think about this, think outside the box, break these points apart. Remember, one point in a paragraph question always leads you to the next. So never, ever, ever leave paragraph questions unanswered. And another one, they said you must write a paragraph, which means you need to write in paragraph format. Always write, always answer paragraph questions in paragraph format. Otherwise, you are going to lose marks. Always ensure you follow the instructions so you get marks, to avoid losing marks unnecessarily. So those are some of the negative impacts on agriculture of mid-latitude cyclones, or of a cold front that is associated with severe rainfall and cold conditions. Okay, next question. Study the synoptic weather map in figure 1 and answer the questions that follow. So this is figure 1, and it is sourced from South African Weather Bureau, and this is a question from the November 2014 Geography National Senior Certificate Examination. Now let's study our synoptic weather map. You'll notice that we have a series of fronts here. So you have your fronts connected to each other here. And what do we call that? It's a family, right, of mid-latitude cyclones. Remember that concept. And again, you have a weather station in the side. It means they may give you or ask you to answer a question on that. So the question says here, 1.1, give the term used to describe the linked mid-latitude cyclones on the synoptic weather map. We just said that that is a family of mid-latitude cyclones. So that is the okay. Question 1.1.2 says refer to the mid-latitude cyclone A. So this is A. And question A says draw a labeled cross section of fund E. Now fund E is here, and fund E has the triangle symbol, as you can see there, which means it's a cold front. So if you are to draw a cross section of fund E, you'll have your reference line there, and you'll have your inclining line or your steep line. So the cold front line is always inclining or curved, simply because it demonstrates or stands for the steep pressure gradient force that is experienced in the cold front. So it will always be curved. And since you are doing a cross section, it means you are not allowed to draw the symbols of the front over there. So it has to be just the inclining line over there. And then another aspect of it, you have your cumulonimbus clouds in front of your cold front. Okay, so you'll have your cumulonimbus clouds over there, and we use the symbol CP to just demarcate that. And in front of the cold front, you'll remember that you always have your warm sector, right? So just demonstrate that you have your warm sector there. And then behind the cold front, you have the cold sector, and the cold sector has what? Cold air. So cold air in the cold sector. Yeah, so those are some of the labels. And how does it move? It moves from the west to the east. I'm using the mouse, getting better. So that's your cross section. Now describe one weather change associated with passing of front E. What is front E? We said it's the cold front. Same question you see, guys, again. What happens to the temperature? It decreases. What happens to the pressure? It's going to increase. Remember the relationship between the two. the wind direction is going to change, and we call that change arcing. We're gonna have heavy rainfall. Why? Because the cloud cover is cumulonimbus clouds or overcast, and they are associated with heavy, severe rainfall. The air pressure will increase, as we said. We'll have cumulonimbus clouds, and the wind speed will increase, and the humidity is gonna decrease. Why does it decrease? Because we have cold air in the region, remember that, and there is a possibility of snowfall in the high-lying regions as a result of this. 1.1.3, refer to the weather station at Windhoek B. So Windhoek is somewhere there. Let me just get a laser. Somewhere there on the map, that is B, Windhoek. And they say in a paragraph of approximately 8 lines, describe and give reasons. Sorry for that again. Remember, guys, I'm at school, so I just paused the video while there was an announcement made on the intercom. So for now, let's get back to the question. So you were asked to describe, write a paragraph of approximately 8 lines, describe and give reasons for the 2 weather conditions recorded at the weather station. So this is the weather station we are working with. Now, before we can do that, I just want us to practice on how to work with weather stations and revise what you did in grade 11 and 10. Now, take, for example, this weather station that is on the screen now. So, if we look at it and try to analyze it, there are different elements, and they are not decorations, guys. There are different elements that you need to take note of when you're analyzing a weather station. So we think about the temperature. So we think about temperature, and what temperature? We think about air temperature. So guys, I'm writing with my mouse, that's why the writing is a bit skewed. And we have a different kind of temperature that we also look at, and that is the dew point temperature. So I'm just gonna say temp. Ooh, this is a mess. But you get the point. And then what else do we look at? We look at cloud cover. Just gonna use the symbol CC. And what else do we use? Forgive me, guys, for the skewed writing. We also have the precipitation. So I'm just gonna say press. When it wants to write properly, it does want to write. What is it? It writes properly. Yeah, so we have precipitation, and then we have wind direction. Wind direction, I'm just gonna use WD, and we also have wind speed, WS. So let's populate these aspects. So what's the wind speed? The wind speed is determined by the arrows or symbols you get there. So we have the feather-like symbols there. So we have the long symbol here, another long one, and a short one. Each long symbol stands for 10 knots. Each short symbol stands for 5 knots. So if we count, this is 10, 20, and 5, 25. So wind speed is what? 25 knots. Yeah, so that's the wind speed. And again, we have wind direction. So remember, guys, you need to always write your units, of course. So this is knots. Yeah, so that is 25 knots. And then we also look at wind direction. So wind direction, in which direction is this facing? If you look at it, it's facing in the easterly direction. So this is east. So the wind direction is east. Or you can say north of northeast if you want to put it like that, because it's a bit skewed towards the north. So you can say north of northeast. So that can be acceptable. Precipitation, we have this symbol here, and that stands for thunderstorms. So thunderstorms, that's the precipitation. Air temperature is 30 degrees Celsius. Remember, this is looking at temperature. It's 30 degrees centigrade or Celsius. And dew point temperature is 18 degrees Celsius. Remember, dew point temperature is the temperature at which condensation starts, at which condensation begins. And then we also look at cloud cover. Cloud cover is overcast. Oh, forgive me guys for my skewed writing. I promise in the next video my writing will be improved. So those are the symbols that we look at. Now let's try to answer the question that is here. Now we are looking at the weather station there. Now what's the air temperature? The air temperature is 27 degrees. So I'm just going to start with wind speed. Oh, we started with wind speed last time. So wind speed is 5 knots. Remember this feather is coming from the center. We don't have the longer one, so that is 5 knots. And what's the reason for that? We have a gentle pressure gradient. The isobars are further apart. So if you look at wind hook there, let me get a laser. Wind hook there, the isobars are further apart. So the pressure gradient is very gentle. And then what's the wind direction? That is northwest or northwest of northwest. So that is acceptable. And why is that? We have air diverging. Diverging is air sinking. Remember, this weather station depicts winter conditions simply because we have mid-latitude cyclones. We have air diverging. Remember, when air diverges, it's when it sinks and divides or move further apart. So that is divergence, and it is happening in an anti-clockwise direction around the high pressure that is there. So the high pressure in the interior, by the way, is the Kalahari high pressure cell. Remember, this is winter, so you'll have your anticyclonic or anti-clockwise movement of air, which takes it to the northwesterly direction. Next one, air temperature is 27 degrees Celsius. Always put in your symbol, otherwise they will mark it wrong in the exam center. Cold, what's the reason? Cold air descending from the high pressure cell warms up adiabatically. What does that mean? It means that for every 100 meters the air goes down or sinks, it increases with 1 degrees Celsius or centigrade. So that is what happens. So when it gets to the surface, it will be high in temperature. Even though it is winter, the air is hot, but it is still dry because it's warming up adiabatically as it sinks from the Kalahari high pressure or from the high pressure system that is at the interior. And the dew point temperature is negative 12 degrees Celsius. So since this is winter, there is less evaporation. So as a result, we'll have subsiding air, more subsiding air, and this reduces the relative humidity of the area, and as a result, you'll have that. The cloud cover is 1/8, so that line is it stands for 1/8. And why do you have 1/8? Because there's very little cloud cover in the area because there are low levels of moisture, and subsiding air heats up and does not condense. So as this cold air sinks, it does not condense. Remember that water vapor is the only thing that condenses. And there is low relative humidity. And the last reason is that if you look at precipitation, that's another feature, there is no precipitation. And why don't we have precipitation? Because subsiding air does not condense. Remember, cold air is dry, it does not have moisture, so it will not condense. And as a result of limited cloud cover, again, we won't have precipitation. And again, there's a large difference between dew point and air temperature. There's a large gap, and because of this gap, we won't have precipitation as a result. So that's how you answer questions on mid-latitude cyclones associated with synoptic weather maps. I hope that was beneficial for you. Let's look at the last question. The last question wants you to answer questions related to satellite images. Satellite imagery. So it says here, refer to the satellite image below, figure 2.3, showing the position of an approaching low pressure system west of South Africa. Read the accompanying weather forecast before answering the questions that follow. So this question has two sets of features or things that we need to study in the annexure. We have the satellite image, as you can see. We have a spiraling towards the center there, and it goes out. If you look at it, so I'll say you'll have your low pressure somewhere there, and where you have your thick clouds here, that will be showing you your cold front. Remember, your cold front has thick clouds, cumulonimbus clouds, and where you have scattered clouds, that will be for your warm sector over there, or warm front. So let's look at the weather forecast. It says satellite image. That was a satellite image showing the approaching low pressure system on Monday, the 30th June 2008. Now here's an extract. Keep your winter woolies out. Tuesday, 1 July 2008. Nice clear skies with cool temperatures can be expected for Tuesday and Wednesday. But people in Western Cape need to brace themselves for another few cold, wet and windy days from Thursday, the 3rd of July 2008. The South African Weather Service has been issuing advisories for these approaching system since the beginning of the week. On Thursday, the gale force northerly to northwesterly winds are expected between Cape Columbine and Cape Agulhas, accompanied by very rough seas with wave heights in excess of 5 meters. Very cold conditions over the western interior of Western and Northern Cape, spreading to the northern interior of the Eastern Cape and Southern Free State can be expected. The colder conditions are expected to reach the northeastern parts of the country on Saturday, with temperatures falling into the cold category. Isolated heavy falls of rain, which could lead to localized flooding, are expected over the peninsula, Bowland and Overberg areas on Thursday and Friday. The South African Weather Service appeals to the public to forward to them any reports or confirmations of significant weather events such as snowfalls, hailstorms, heavy rains, damaging winds, etc. So these are weather conditions, by the way, associated with this system. Now it says when they are observed, of course, when they are observed, they need to be reported. So now, such information can also be used for further research, which will contribute to the improvement of weather prediction for that particular area. So now that we're done studying the annexure, and you see that this is about a mid-latitude cyclone, I mean, that is clear. Now, question number 1 asks you, identify the low pressure system labeled K. Now, if you remember K on the satellite image, that was a mid-latitude cyclone, also known as a temperate cyclone or a mid-latitude depression or an extratropical cyclone. So those are alternative names of a mid-latitude cyclone, or temperate depression. So those are the names. So that's the K. 1.2, during which season does the above mentioned low pressure system usually affect the weather of South Africa? Now, remember, mid-latitude cyclones occur throughout the year, but they only affect South Africa in winter. Why don't they affect us in summer? It's because in summer, the ITCZ moves from the northern hemisphere, as it will be winter, to the southern hemisphere. And when it moves to the southern hemisphere, it causes the high pressure systems at the 30-degree line of latitude to be pushed further south, which inhibits or blocks. It causes these high pressure systems to act as blocking high pressure systems, inhibiting the mid-latitude cyclones from affecting us in summer. I hope that is clear. So remember, there's a part in the exam guideline that asks you of the effect of or the influence of the South Atlantic and South Indian high pressure cells on mid-latitude cyclones. So when they are when the ITCZ comes in summer to the southern hemisphere, it pushes these high pressure cells further south, and when they are pushed further south, they block the mid-latitude cyclone from passing into the interior. Now, why don't mid-latitude cyclones jump this system? Remember, the South Atlantic high pressure cell and South Indian high pressure cells are high pressure systems, which means they're associated with cold air. And remember the fact that cold air and warm air will never mix, but they meet, which means when the subtropical anticyclones are pushed further south, when the ITCZ comes to the southern hemisphere, they block these mid-latitude cyclones that have formed between 30 and 60 degrees from getting into, or rather from passing towards the interior. And as a result, we won't have mid-latitude cyclones affecting us in the summer season. It does not mean that they are not there. They are there, but they can't affect us because of these blocking systems. Now, so in which season do they then affect us? It is in winter. Why in winter? I explained that in the previous questions to say that when it is winter in the southern hemisphere, it means it's summer in the northern hemisphere. And since it's summer in the northern hemisphere, it means that our ITCZ will go to the northern hemisphere. And as it goes or migrates with your high pressure systems, it is going to, when it goes to the northern hemisphere, it pulls with it these high pressure systems back to the 30-degree line of latitude, and as a result, our mid-latitude cyclone will affect the west coast of the country. In which season? In winter. So that's the reason for that. And now you also know the effect of these high pressure systems in mid-latitude cyclones. 1.3. Give the general direction of the movement of the low pressure system, usually mentioned in 1.1. We said 1.1 is a mid-latitude cyclone, and mid-latitude cyclones are found in which belt? In the westerly wind belt, which means they will always move from west to east because they are driven by tropical or subtropical westerlies. So they move from west to east, or eastwards, or towards the east, or to the east. So that's, choose the better way to put it, but that's how they move. Important factor there to consider. Next question, give one reason for direction of the movement of the low pressure system as mentioned. So I've highlighted because of the westerly wind belt, because they form between 30 and 60 degrees where we have westerly winds dominating the region. These systems will thus be moving or be driven towards the east as they are driven by tropical or subtropical westerlies. Now it says here, draw a sketch map of the low pressure system appearing in the satellite image above, indicating its position in relation to South Africa. So you'll have your diagram of South Africa there, you'll have your system there, and you'll have your cold front. It has your triangle symbols, sorry for the unevenness, and you have your warm front there. So that is your system, that is the system in relation to South Africa. So you need to label it, that is the cold front, So that is the warm front, and this is the warm sector. This is the cold sector. Ooh, sorry guys. Let me just rewrite that. This is the cold sector, and it has cold air, right? And this system moves from west to east. So that's how your diagram should more or less look, or here is a clearer one. Okay, 1.6. Why is it important for the South African Weather Service to issue warnings? Use the source above to write a short essay, no longer than 12 lines, clearly indicating the value of weather focus and warnings. In your answer, also indicate how reports forwarded by the public can improve weather focus. So now they will usually say now a paragraph of no longer than 8 lines, right? So it's no longer 12 lines. This is an extract from a question that was done in Learn Extra, Mindset Learn Extra, years ago. Okay, now in your paragraph question, we are looking at the value of weather forecasting. Why should we predict weather? Number one, we predict weather and issue out warnings to warn people in advance or timelessly. Again, we also give them, we also do that so that we ensure that we have, or rather we apply precautionary measures that may be necessary to counter the dire effects that will come with the system. It also allows for evacuation to happen on time. It also ensures that we prepare for the harsh weather conditions to protect people. It also warns fishermen to not go to the ocean during these times. It also helps us plan our outdoor activities, so we cancel them in such an event. It also ensures that we also prepare our rescue services beforehand, so we are more organized to try. So we avoid the loss of life and decrease the dire effects of this. Of the systems. And again, on tourism, it also ensures that tourists can adjust their plans so that they are not negatively affected by those systems. So you just remember, it's a paragraph question. You always write it in paragraph format, but you also give these questions, or rather these responses. So this wanted you to think outside the box, apply your knowledge, and think about how, or rather the value, or how valuable our forecasting and warning systems in a country. So that is the last question, I believe. Thank you for listening. So let me just give some last tips on mid-latitude cyclones. Ensure you know the following for mid-latitude cyclones. What are they? What are mid-latitude cyclones? And what do we look at in the what section? We look at concepts. What concepts are special or significant to mid-latitude cyclones? What characteristics do mid-latitude cyclones have, and how and where do they occur rather? So that is question number 2. Where do they form? And when do they form? When do they affect us? When do they affect certain regions? How do they affect those regions? How do they form? How do they affect certain regions? How do they look? So we look at cross sections and diagrams, and how do they affect humans, the economy, and the environment, and why do they have the effects that they have, and why do they form? Why do they have the effects that they have, and how can we counter them, obviously. This is a list of references for this presentation for copyright reasons. So all the questions discussed here are an extract of the DPE November 2020 question paper, the DPE 2021, May-June 2021, NSC and SC grade 12 geography question paper, Gauteng Department of Education, Sai Bono SIP material for the quiz, and Mindset Learn Extra resources. So there is a list of your sources. You can check out those question papers for your own personal gain. Thanks for listening. Look out for the next video on our revision series, which is on tropical cyclones. Oh, and coincidentally, the bell just rang, so it shows the end of our session. Thank you very much for your time. Thank you for listening in. All the best with your exams and your revision, and hope this video will assist you very much in preparation for your examinations. This is Mr. Peter Mbuyisa, Mr. P. Mbuyisa, and I am humbled and happy to offer you these services from the Pedagogical Science Institute, where we do what we do for the people. Thank you very much.